Still a little stoichiometry. Now, with stoichiometry, it's really an easy thing. We don't want to make it hard. Just think of it like a cake recipe. You're either scaling something up or you're scaling something down. You have to have a balanced equation. Has to be balanced. So before you do a stoichiometry problem, don't ever trust that that equation is balanced. Always double check. 4 hydrogens, 2 oxygens, 2 oxygens. So we're balanced. That makes it easy for us. Now, in this one, you've got 2 ways that you can be asked a stoichiometry problem. Well, on this test, you've got 2 ways that you can be asked a stoichiometry problem. We can say how many moles of water, or how many moles are you going to get whenever you're given so many moles. Well, those are easy because you don't have to do any conversion, like from gram to mole conversions. So let's take this problem. How many moles of water are we going to get are produced from 10 moles of hydrogen gas? Okay, so remember, you have to have a ratio. And remember, your ratio, of course, has to be a mole ratio. Okay, and we have moles here, so that's easy, that's good. We don't have to do any conversions at this point because we're given moles. The way you get your ratio is the number on the top is like your given information in your problem. Okay, that's like what you actually have, or you might call it your given info, but that goes on top. Okay, so the 10 moles go on top, and then the number on the bottom is your coefficient from the equation. Okay, so the coefficient in front of our hydrogen is 2. So the number on the bottom is 2. If you get confused, just say, okay, if I want to make 2 batches of cookies, it takes 2 cups of flour plus 1 egg. Okay, well, I've got 10 cups of flour. So that means I can make, 10 divided by 2. I can make 5 times as much cookies. Okay? So our ratio here, remember ratios are unitless numbers, in this case is 5. Okay, we're scaling it up. So instead of making 2 moles of water or 2 batches of cookies, I'm going to multiply that by 5. So 2 times 5 means that I'm going to make 10 moles of water. So those are really easy because you don't have conversions to do. But in real life, we deal with grams because we have scales that weigh grams. We don't have scales that weigh moles. So in this case, we've got to do some gram to mole conversions. Okay, so we're dealing with oxygen. Our given is 75 grams of oxygen. So that means that I'm going to have to know the molar mass of oxygen. Okay, I'm dealing with this right here. The molar mass of oxygen, remember this is a diatomic. So O2, that means I have 2 oxygens times 16 grams per mole. Okay, so that's 32 grams per mole. That's my GMW for that diatomic there. And I'm just going to put this to the side. I know I'm going to have to, if I've got grams in my stoichiometry problem, I know I have to have my molar masses or my gram molecular weights, whatever you want to call them. So I'm just going to do this. That way I have it and I don't have to worry about it later. Okay, water, H2O. So you've got 2 hydrogens times 1 gram per mole, so that's 2. 1 oxygen times 16. So the molar mass of water is 18 grams per mole. I'm just going to stick those off to the side because I will need them for later. Okay. So I'm given 75 grams of oxygen. In order to come up with my ratio, remember my ratio has to be in moles. Okay, you got to take the moles that you're given, and we're not given moles, we're given grams. And we have to divide that by the moles, which are, the coefficient for the equation. So I have to convert the 75 grams of water, or excuse me, the 75 grams of oxygen that I'm given in my problem. Okay, so for oxygen, 75 grams, and we're going to divide that by 32 grams per mole. So 75 divided by 32 gives me 2.34. Okay? So I have 2.34 moles of oxygen. So just like I did up here, what I actually have, the moles of oxygen I actually have are 2.34. The moles of oxygen in our equation is 1. It only calls for 1 mole of oxygen in that equation. So I divide that by 1. So my ratio is 2.34. So now how much water am I going to get? So if I look up here, in this case, I have to take this 2 moles times my ratio, 2.34, and I'm going to make, if everything goes well, 4.68 moles. Okay, if I don't mess anything up, I should make 4.68 moles. Okay, so 4.68 moles of water. But again, that doesn't do the normal person a whole lot of good, because we tend to want to have mass that we can weigh on a scale. So I'm going to convert that to grams. It's 18 grams per mole for water. So 4.68 times 18 gives me 84 grams of water. Okay, I just rounded, but 84 grams of water.